So with that said, I will give a little bit of introduction. So I did my undergrad at Stanford. That's when I was doing ICPC, I guess, as a participant back in, as mentioned, 2010, 2011 time. I went to MIT for a PhD, although I didn't finish. And I think I was actually helping 1 year in 2013 season, I believe, as an assistant coach there. Although one thing I can tell is they didn't actually need a coach. They can actually self-serve. So it was a sort of like a interesting time to learn how how they kind of operate and what they practice on things. So I'm hoping to shed some light on that today. And there's a in the middle of doing the MIT thing, I was actually fortunate enough to get a job at Google. So I did that for about 6 years, and then I moved to New York, working in Columbia, teaching part time, and also working full time at Two Sigma. And now, and then over the years, I was doing some workshops and coaching, and taking on some part time jobs and such. And now, I am quite fortunate to work in the ICPC, in various different dimensions. So one is ICPC internship manager, and the other one is being part of the leadership team. And for those of you who are going to the North America Championship, I'll be in the trainer for the programming camp in May. So it's like a joint program with NAC, North America Championship, and a programming camp. And I think actually soon, as in March, we'll start doing some online training as well. So I'm hoping to do some of that. And I've been serving as a judge for last couple of years, on top of just teaching part-time at Columbia, as I said, and then doing some startup and consulting and head coaching Columbia. So that's me. And then I guess last but not the least, but maybe we can have Ben and Chris introduce themselves. So Ben, would you like to have a quick introduction of yourself?
Yeah, sure. I'm Ben Reed. I'm a professor in computer science at San Jose State University. I've been here, this is my 6th year here. I was in industry before. Yay. Gentleman kicked me out. Yeah, so I work on operating systems, networks, and distributed systems. And I got my PhD from UC Santa Cruz.
Ooh, nice. That's like where all the wild things appear from time to time. Because I I
Yeah. The grad program is a little bit different from the undergrad program. We're
oh, I
we're a
see.
little less crazy. So
Yeah, so I had an experience of like I think teaching one or two semesters there, and when I was the two time I visited, because I was in over the COVID time, so actually everything was remote. Wildlife just appeared out of nowhere, and I think
oh yeah.
bull or something was chasing our car, and we had to actually dodge. And so
Yeah, it's a
yeah,
nice campus. Very beautiful.
yeah, for sure, for sure. Yeah, great. And Chris.
Yeah, hi everyone. I'm Chris Marriott. I'm actually the Deputy Director of the Pac Northwest region. I'm here on behalf of Tom Kapal, who you probably would recognize as the director of this region if you've competed before. I am from Canada. I'm from Calgary. That's where I did my education in computer science. I now am at the University of Washington. I'm a professor in computer science. I usually teach algorithms and data structures, and I also teach a games course. My research is in artificial intelligence and artificial life. And yeah, I want to just welcome Christian again. Thanks again.
Yeah, for sure. Thanks a lot. It's quite. I wanted to say that like one thing, a few things, because I actually am from the Pacific Northwest region. I guess a long time ago, 2010, 2011. So I really appreciate the effort. I guess invitation to run the workshop. And I guess secondly, it's quite a pleasure and honor to be here. Of course, I forgot to mention that. And Chris and Tom are I think, well, in my opinion, the best, deputy director and director. And so you guys are in fortunate hands, that's for sure.
Thank you. Thank you.
And so, yeah, great. So with that said, let's, push forward with some of the materials. And as I said in the middle, we'll take a quick pause and then we'll go to the part 2, right? So, and based on my experience of running the similar things before, it seemed like number of you are actually going for the industry positioning and such. So the part 2 will be about, exclusively discussing how to have the best shot in preparing and also landing a job in the industry, right? So yeah, that's how I kind of prepare today. Of course, we can do a bit more in the future if needed, but let's start with this. Yeah. All right, so the general introduction, part one, and part two, interview preparation guide, right? So there are two sort of, I want to say similar and interlinked topic, but maybe a different topic, let's say in a strictest sense, yeah. So the popular contest sites, how many of you actually heard of sites Adquarter, Codeforces, Topquarter, LeetCode? If you know at least one of them, then put a thumbs up in the link. Yeah, so that's good. I want to say that the sites Adquarter and Codeforces, they are popular sites for sure, but the timing is not really Pacific Northwest friendly because Codeforces contest happens at 6:30. a.m. Pacific time, and then Adquarter starts at like 3 a.m. and 4 a.m. Pacific time. And so my recommendation is that they do have a virtual contest features, and I think in order to make sure that you kind of get let's say let's say checking your current skill set, it's good to do the virtual contest to know exactly where you are. But my recommendation is for those of you who are living in the Pacific Northwest, is probably not the best idea to wake up consistently at the 6:30 and 3 o'clock in the morning to do them. I used to do them, but you can think of me as I guess the exception in that I didn't sleep well at the regular time. I would go to sleep at 10, typically just the day before the contest happens, because otherwise I'll miss them. But as a college student, I think I can almost argue that like a 4 a.m. or so is when you actually go to sleep, right? So it's probably not the best timing, but in terms of popularity, Codeforces is definitely among the top contest platform now. Topquarter is there for the historical reasons, but it's not as I guess popular as it once was in the 1990s and 2000, maybe 2000. Towards the end of 2010, I think the Codeforces picked up, and that quarter appeared around 2010 and 2020. But nonetheless, those are great contest platform. Codeforces, there's a live contest that you should do that happens like every week, or 3 contests every 2 weeks in roughly. And at quarter, it's like there are 3 different level of contests, but the at quarter beginner would be recommended, and they happen pretty much like every weekends at 3 o'clock Pacific time. They're given 7 to 8 problems to do for I think 100 minutes or so. And Codeforces is 2 hours or 2 hours and a half to solve 5 to 6 problems. And Topquarter is 3 problems for 75 minutes. And like there are some, I guess the hacking phase and otherwise. So it's a interesting try. Let's call it 3 websites they can practice to make sure that you're honing skills towards ICPC or programming contest, right? And I guess the other one, the LeetCode is more for, as you know, interview preparation. So it doesn't really, I guess, prepare you well or adequately for the programming contest ICPC. Although, like for, interview preparation, especially for tech companies, that's definitely one of the popular choices, right? And I do see a few more people who just joined. So maybe after, maybe in the break, I can actually go back and ask them to introduce themselves. But yeah, so, and I guess as some of you might know, there are like practice sites that are not, let's say, giving you the ratings and such, but they do have a archive of problems that you can solve. Caddis is created by Frederick Nimela and other people, Greg Morissette. But what I know is that site is great for ICPC, especially because they have I guess a giant pool of problems that are from the previous ICPC contest, including Pacific Northwest. And so best way to prepare for contests like Pacific Northwest and North America Championship and World Finals would be to look at the previous one that were there, and just try to find out the pattern or like the problem types that you may get thrown into in the contest, right? So there are like let's say I would say past 5 to 10 years of each of the contests might be the most relevant. And if you check the Pacific Northwest problem set are available mostly in Caddis. And CSCS is a companion, like a problem-solving site. That goes hand in hand with the Guide to Competitive Programming by Antti Laaksonen. So if you go to this site, then you'll see that there are like a number of problems you can do, and you'll see that there's a problem on sorting and searching, dynamic programming, graph algorithms, range queries, tree algorithms, mathematics, and string, geometry, and advanced ones, right? So and then they have more exercise as well. So there are only 300 problems in total in the CSCS. So my recommendation is, if you do have time, take a look at them for sure. And then OpenCaddis is also another site that that is popular sites to go. I guess throughout the semester, I typically am not active, so you'll see my I guess rating decrease over the semester. But during the breaks are usually when I actually try to speed solve as much as I can. And one way to use the problem is by going to problems and let's say click on the solved so that you don't actually have to solve the ones that you solved before. And then sort them by ascending order or by difficulty. And also, when you actually look at the problem sources, you can actually see that what problems are useful. And that's why that's where you can actually search for the problems in the Pacific Northwest and focus on the problems in that, coming from the Pacific Northwest only and such, right? And I want to introduce you to this wonderful guides that there are. So USACO guide have sections, let's say bronze, silver, gold, platinum, advanced, they can choose from. This fantastic guide, I guess, started by Benchi, but now there are a lot of other people who are investing their time on this. So when you go down, when you actually see like the creator of this, you'll see that most of them have done the USACO in the past. So USA Computing Olympiad, and they've been active in the competitive programming platform for a while. And this another site, CP Algorithms, have a wealth of information on algebra, the I guess dynamic data structure, dynamic programming, string, linear algebra, so on and so forth. So you'll see that those two websites collectively actually are, I think, enough for preparing most of the nuts and bolts for preparing for the ICPC contest. Let's say up until the North America Championship for sure, and potentially for World Finals as well. And along with Ben and other people within ICPC, we also do have the curriculum committee that meet every other week to actually prepare something that may be helpful for the ICPC community. So in the future, you might hear from us more in the North America Championship and maybe in the World Finals, where we'll tell you that there are some wealth of information coming from the committee as well on the curriculum. So more to come, of course. And there are some trackers that I want you guys to know about. So there's a CF tracker, as you can tell from the name, and then there's a visualization ones. So Code Forces Visualizer actually tells you what problems you solved in the past. For example, if I click on this, I think the Code Forces server is down, so maybe it's not going to be possible to see. And then there's this site that tells you what problems there are. And then there's also like a visualization. Yeah, so the Code Forces platform is down, so we cannot actually get the information, unfortunately, right now. But if you visualize, then you'll see. And one of the best way to use the tracker is it tells you what problems you actually have solved in the past and what problems you haven't. So for example, if you're used to solving problem B, and then let's say problem C, D, E, and so on are the something that gives you the most trouble, then my recommendation is, let's say you can solve up to C, then you want to get to D and then solve those questions, let's say going down one row at a time. And CF tracker, there are two of them. So this is one of them, and then this one is a little bit more visually friendlier. So either one works, but my recommendation is the most probably the best way to use this is go down like one column at a time, and then try to knock out as many questions as possible from them, right? So when you actually see the Code Forces platform, you'll see that it's actually hard to keep track of, for each problem level, what you solved and what you haven't solved. But those trackers actually give you a very good way to see like what you have done and then what you haven't done, so that you'll know what exactly to do as you progress towards like solving most of the questions, right? And as frequently asked question, how much do you actually have to solve in code forces to really do well in the respective contest? And I think the typical bar that I'd like to give is, if you're competent, as in if you want to go to North America Championship from, as Ben mentioned, the hard region as Pacific Northwest, then I think solving 4 or 5 problems in Division 2 would be quite important. And then from the North America Championship to the World Final, if you want to make it to the World Finals consistently, I think solving 5 on average would be quite important. And then once you get to the World Finals, like medal zone or not, I guess if you'd like to medal, I think solving, let's say all questions in Division 2 is probably important, but let's say to put the realistic goal, like solving all the questions in Division 2 would mean that you're like code forces, I guess grandmasters and things. So as a starting point, it may be a bit ambitious, but I think it's certainly possible if you grind in the right way. And I certainly have some students or mentees who actually achieved the grandmaster level, starting from, let's say, like a novice or like a pupil. So it's certainly possible, but it does take quite a bit of effort, and also, let's say, dedicated, energy to push through. But my expectation is getting to the North America Championship from the Pacific Northwest could be one like a reasonable goal to target for. And I do believe that it's definitely possible if you put in the effort in the right direction. And that's one of the reasons why I'm here, to tell you that like going to North America Championship is definitely reasonable / feasible goal if you attack the questions in the right direction, right? And then if you do, I guess, consistent practice throughout the week. Yeah. Okay, and now the more on the growing short list of useful website. So you can actually see some websites that I actually collected over the years. So you can actually see them. Oh, those are the things that that are like some sites that I didn't list in the slide that might be useful. For example, CP4, UVA, and so on. And then let me actually share this slide with all of you here so that you'll see what I'm going to talk about over time. And in case you have to leave early and so on, you have the at least a slide deck with you so that you know what to do, right? So the growing list of useful websites, I would definitely recommend like you reading through them at least once, and then find out what websites you like to use. Chances are you may have seen it all, but there might be 1 or 2 sites that you actually haven't seen before. So I definitely recommend that you're going through them. And then there are some TERS guide that I've written over the years as well. So you can read, guide to system design interview, live contest, ICPC preparation, behavioral, TERS useful. I mean, the TERS list is something you've seen. And maybe this one, a way to practice competitive programming so they can get from 1,000 to 2,400. That will be, very useful guide for those of you who are very ambitious about your problem-solving regimen. Yeah. And there are some textbooks that I would recommend as well. So one is Competitive Programming 4 by Halim, and in the 4th version, Suhendri actually joined the force, and they have 2 book volume on the competitive programming topic, and that's very important topic. Well, a very important book to prepare, and I think most of the things that they say, and the companion GitHub links are very useful. And I certainly, peruse the book, and then each time I read them, I learn different things. And so it's a very, effective textbook for learning the nuts and bolts for competitive programming. And then a bit of theoretical, I guess, a spin on the learning algorithms, but nonetheless, I think is a good textbook to read. Would be Corman's or the Corman and Lyserson, Rivest, and Stein. So CLRS on the introduction to algorithms. So it's standard algorithms on this standard textbook on this domain on algorithms. But as I said, it's a little bit theoretical, and most of the codes are available in pseudocode instead of actual code. So it might be a little bit hard to use in terms of being able to actually put them into practical notes, but my recommendation is, if you want to learn about the theoretical, I guess, side of algorithms and how to prove things, in addition to seeing some standard exercises on each of the domain, then I would definitely recommend using this book. For example, greedy algorithm, it goes through, I guess the optimization theory, like why does it actually work, and it goes to material theory to actually establish that like if you have this XYZ condition, then you have a greedy, and it's maybe those chapters that actually give you a bit more information other than what's typically available in the practical textbooks, right? So I would definitely recommend this. And the programming language choice, actually, this is probably a popular question for the audience here, but who actually uses, let's say, if put thumbs up if you are using the language. So who is using, let's say, C++ when you're doing day-to-day, comparative programming? Okay. So a couple of you, who are using Python? If you're using Python, then put a circle, maybe. So some of you, okay. And finally, who is using Java for programming contest? So, and I'm gonna guess that Ben, you're using Rust, is that right?
I wish.
But okay. And then Chris, how about you? What do you recommend the students typically use, I guess, in the programming contest? Do you have a language of your choice?
My language of choice is JavaScript, and that does not work very well in a programming competition contest. But a lot of my students are Java programmers, so I usually am letting them know that that's perfectly fine. But if I had a choice, I'd probably use Python.
Oh, really? Oh, C++.
Yeah.
Okay. So I guess there is a Rust user in the house, Ben, and C++, me, and Chris with Python. So I guess, let's say like, any language is actually okay. So I think I was being a little bit too strong on the opinion here, but C++ is probably like a pretty dominant language to be used in the code process domain, just because runtime and, the fact that you'll never be able to actually get in like let's say time limit exceeded issue just because of the language features, right? So that you can avoid through C++, but by doing so, I do think that you introduce let's say a lot of complexity in using pointers, and ampersand and star in particular are like a very I guess quirky features of C++, and so the people who are first getting introduced, Python is perfectly fine. And so Python is probably like a reasonable choice for people who are trying to implement quick things. And the Java would be somewhere in between, in my opinion, and then C++. If you really want to get to quant, or I mean quant as in trading companies, or like, if you really care about the runtime and such, C++ could be a good choice. But and typically for a comparative programming course that I teach, I ask them to convert to be a C++ programmer. But in the future, though, I think with the Python getting better and better with PyPy, the optimized version of Python, I think the gap might close up sooner than later. So like how much I would actually emphasize C++ over time, I would expect I'll emphasize less and less over time. So I guess Mary's Mary's comment is actually I guess insightful. So there's no time multiplier for submission, so Python times out a lot more than C++. Yeah. So even if you have optimal time complexity, so that is actually true. Well, I'm not sure about how the Pacific Northwest works, but in the greater New York, I think that's strongly true. And so yeah, I mean the moral of the story is, if you can use C++, please do use them. And then I think for becoming serious competitive programmers, in like if you want to solve some of the tough problems without having to worry about the runtime, because all the solutions are at least checked in C++ environment, it might be a good idea to at least have one person in the team who can write competently in C++. So not everyone has to write well in C++, let's say, but one of you, it'll be a good idea, right? Okay. Yeah. And then I guess one thing I will give everyone in the audience here, because you're obviously enthusiastic about coming to the workshop on Saturdays, is if you'd like to set up a quick one-on-one chat with me, please sign up so that we can chat about how you can actually set up the goals for programming contest, and also talk about I guess some job related things, or if you have anything that you worry about, it might be a good time to actually tell me. I'm not saying that I have all the solutions or all the problems solved by coming, but we can definitely talk about some of those issues, right? So, all right. So with that said, I do like to tell everyone that there is a Discord group that we have a weekly practice contest in. So please join them. It'll be a good site where you'll get introduced to weekly and weekend problem sets. And then we hold master classes through ICPC Foundation internship on Sundays. And the weekend problem set that happens from Friday to Sunday, we actually go through each and every problem that are proposed there. So if you want to learn about some problems that you saw, I mean, try to solve on that Friday to Sunday contest, but you weren't able to, then there'll be a sort of like a walkthrough that we do with these slides, and I guess the interns actually giving presentations. So please check that out. It'll be a good way to learn, and make sure that your momentum for learning actually get I guess fueled with more problem solving, right? So I know I'm aware that like most of the schools would have some training through, I guess, their own like weekly practices and maybe biweekly and so on. But this practice will be in addition to that. And I think for some schools that actually do not have such practice sessions, then this will be quite a good way to, as a community, come together to learn how to problem solve together, right? So I highly recommend this for anyone who is interested. Yeah. Okay. Now there is I think over the years some things I collected about how to practice and then like a strategies on especially in code forces, right? So I asked, I guess, let's say among the top 10 to 20 folks. I mean, the list is dynamic, but over the years, when I meet them in person, in the various different, the programming contests, so North American Championship and I guess World Finals that are coming soon and such, I do ask them, how did they, basically got better in their rating, and in particular, how do they train? And predominantly, most of them have some versions of what I actually discuss here, which is, if your goal is to get to the code forces rating of X, then they really push themselves to, solve problems that are 300 level above it. So X plus 300. So, with a spread of 100. So, let's say X plus 2, X plus 3, X plus 400 would be quite a sensible range to pick for practice. So if you want to get to red, let's say in code forces, which is like a 2400 as a lower bound, then you should aim for solving 26, 27, and 2800. So the eventual target is really try to solve these questions in under 30 minutes or less. And then what this actually means in practice would be in the actual live contest where you're given 2 hours to do. Suppose that you solved all the previous questions, in 1 hour mark, and you have about 1 hour to go. And so if you can actually solve the next level of question that you're stuck on in under 30 minutes eventually, that means you can actually solve the question during the actual contest, which actually means your rating has to increase from where you are to your desired rating. So that's really the idea behind this practice strategy. And so of course, if you target on solving some rating range that is far and beyond where you're currently comfortable solving, 30 minutes is actually quite high bar, right? So, I think that when you're training up, it's important to pick a problem rating or like a rating range that is just in the right spot for you. And, that's really where the art goes into play. So if you do not know what your comfort rating is, then that's when I can definitely tell you by meeting in one-on-one. And otherwise, based on your previous experience, your rating target should be something like XYZ. And then from there, you can expect to grow in like alpha beta sort of like over time. and then we can discuss the specific plan for your specific case about what you want to do to actually grow your skills. Okay, so, and second thing I would like to mention is, if you'd like to rank up, as in your color change, so color change would mean typically 200 level to 300 rating, plus from where you are. If you want to do that, then you have to solve, I heard about 1,000 problems, which is, let's say, if you want to like to do that in the 3 month, then it'll be about 10 to 15 problems a day. But now, given that each problem will take about 30 minutes to 1 hour to solve, that would come out to be about 5 hours to 10 hours per day. Is that reasonable? During the school time, most absolutely, I don't think so, because you have other works to do. But so my recommendation is, instead of trying to level up to in 3 months, you can try to do it in half a year, and that will mean solving about 5 problems to 10 problems a day, which is actually going to be a lot more practical, right? So this practice regimen, I tried it myself, right? And when I do try, it works during the time that I try. And then I guess when I actually am off the practice regimen and then come back to the let's say the grinding again, then I see basically let's say rating drop, and then I would see, as I consistently apply it again, the rating does increase. But as I said before, during the break time is when I actually have time to grind, and over the school year, I have much less time to do. So I've been seeing, ratings actually fluctuate. But I think based on what I've seen anecdotally for myself and other people, I think this actually some rendition of this, right? So for each person, I'm sure they will apply differently, but it does work, fairly well. I'm not going to say that it works for every single person I know, but it does work, let's say, with a very high percentage of the people that I've seen. So 90% plus. And so I would definitely recommend you give this a try if you haven't already. And this is like a similar to, if you go to a gym, giving you like a practice regimen for how to actually muscle up and things like that. So it's very similar sort of pattern. And one thing that I guess I can tell you is this regimen to effectively work, you typically do not want to have a day of rest. So like a consistent daily practice would be better. Especially, let's say, even if it's like just a couple hours, that's better than doing it every other day. And if you have like a limited amount of time, then what I recommend doing is maybe, just like a couple hours a day to start. And then from there, if you have some more time other times, then you can do more. But it's better than, let's say, you clump and then do like a 10 hours of practice one day, and the rest of the time you actually do not do anything. I am like, what I found is like a daily practice serve you better than, I think, trying to do like a one focused practice just one time during the week, right? So that's typical recommendation I have for everyone. And so this will be a good way to practice them. And where do you practice? As I said, the prior problems that I give will be my recommendation on what problems to solve. But I guess other practice platforms that I gave you, like a CSCS, USACO guide and such, those are all like a reasonable size to practice with, right? And now another thing that I want to mention is, quite often you'll get to the point where you look at the question, stare at it for, let's say, extended period of time, and you'll get to the point where you cannot solve a problem because you either probably do not know the like let's say trick to solve the question, or maybe the trick is actually something let's say not hard but tricky because you haven't actually seen them before. So the typical recipe that I ask is you can look at the editorials for hints, let's say, after you're stuck for some period of time. And then if you cannot do it, then you can actually look at the full solution for the editorial. And then you can actually look at the accepted solutions as well, right, in the platform. And when you do any of the above, though, one thing that you should really, really make sure is 2 weeks to come, you should come back and try to solve it again, because the basically the motivation behind solving the questions. Well, I guess there are two. I mean, it will be a different things for different people, but one of the things that you're trying to do is retain the information that you learned from the practice and also from the problem. So in 2 weeks to come, if you cannot actually solve the question again, then that means like when it comes to the future contest, or let's say future interview and otherwise, you won't actually be able to solve the question when it comes to that. And the funny thing is, the ones that you typically cannot get through practice, those are exactly the one that is going to come and bite you in the actual contest or in the interview. So my like a genuine advice for all of you here is, in 2 weeks to come, if you cannot solve them, then make sure to start them for sure, and then come back again and again until you're very comfortable on solving them. And then once it becomes part of your like a muscle, then you can actually move on to other questions. But generally speaking, when I do like an intense like training sessions, let's say over the breaks, I think that among all the questions I solve, maybe I want to say 1 out of 5 questions actually I do start, because those are the questions that are tough to solve in one go. And then what I do for myself is I would come back again and again. And then there are about like let's say among the ones that I start, maybe about 10% of the questions that I have to come back many times. I would say I've done, in the worst case, I came back like let's say 10 times. So if it's like a 2 weeks and I've done it 10 times, this would be like 20 weeks, right? So about half a year, I would come back and again. But each time I come back, I would learn different aspects of it. And then, but as overall, the problem is pretty tough problem. So I have to come back many times to like basically learn it well. But my recommendation is, until you get to the point where you know it inside out, my recommendation is do not skip the problem, because some like variations of the problem that you couldn't solve are going to be the ones that are going to come and hunt you in the actual like live contest. And so if you do not solve them now, then it'll come back later. So you might as well take care of it now so that you don't see them later in some other obscure contest and you're like, hey, I've seen that before, but I don't quite remember how to solve the question. Those are exactly the ones that you want to spend time on, because they'll come back again and again, right? So it goes to all saying that it's okay to look at the hints, full solutions, and even accepted solutions. In fact, on the top problems that you cannot get to, that's probably the next best thing you can do, rather than coming up with your own solution. But when you do so, come back to them, as many times as you need until you can actually comfortably solve them without looking at any of them. And once you can do that, then you'll be pretty confident that you can solve them in any future contest that come up, right? Okay, so there are of course some Thirst guide I wrote, as I said, on the live contest, so you can read about them at your perusal. And also there is some C++ tricks and tips and tricks that I've learned over the years, and it's coming in the Codeforces platform. And as you see, like Codeforces, the server is down, so I cannot see them. But make sure to spend some time on learning those. And NEA1 is actually one of the team member for Columbia World Final Team, and he wrote some tips for C++ as well. So make sure to take a look at them as you make a transition into C++. And foremost important thing for everyone, the C++ users, you can actually now use this header C++ include bit/std c++.h that has almost all the headers you can think of. So like instead of having pound include 20 different things, let's say, you can actually get by with just using just one header, and then using namespace std to do not worry about the header component at all, right? So my 2 cents is definitely try to use that because it'll save you some time. And even more so, it's probably a good idea to have a template that you use all the time, so that like the header is, the top part of your code is basically same each time. And of course, it's possible that when you go to, let's say, regional contest, the computers that they give you will not have the header saved. So very first thing you might do when you start the programming contest would be have the header and then copy that as you to any other problems in the set. So I would just like recommend that for like a pre-setting purposes. You can notice that some of the topics that I discuss here will be relevant for the ICPC as well, especially algorithm and data structure portion, as we will discuss them soon, right? So first thing first, right? I know that all of you will have to go through this interview preparation if you are going for software engineering. One thing I'll tell you though, the market is a little bit hard or harsh is probably another way to put this. But I think that if you prepare the interview well enough, then I've been seeing some success stories, I guess this year actually, just about like the last couple of weeks actually. So the market might come back to a bit better state, I would expect. So let's try to expect for the best and then prepare for the interview, right? So the technical interview, typically there are two different things. Those are, of course, the technical testing the technical skill sets required for the job. So there are typically two things that are tested: algorithm and data structure and system design. And alongside with the technical interviews, there are sometimes a behavioral interview that like test your soft skills, effective communication, conflict resolution. Do you work well with a team, and can you be effective contributor when it comes to interpersonal skills and so on, right? So technical interview, they're typically, I would say, recruiter call or like online coding challenge or online assessment these days, they're called. They kind of flip and then there's a technical phone screen followed by on-site interview that has 4 to 7 interviews typically. And then, like you'll get some fit calls and negotiations. One caveat that I'd like to say is on this portion, we'll cover the first, let's say middle 3. There is some art with talking to the recruiter to have a best chance of going to the phone screening and such. And also in fit calls and negotiations, you can actually work out the offer details so that especially if you have a competing offer, then I heard that you can get as much as 3 times the original offer that you had. So that's quite significant, but we'll focus on the middle 3, right? So the middle 3 portion, I think, is really the key for getting the offer from the company. Typically, the interview on site doesn't happen for tech companies, especially if you're looking for the internship. But for the full-time, they'll do all of that. And then for quant interviews, typically there is on site even for the internship. They call it like a super day sometimes and otherwise. So this is the portion that I think will be quite interconnected to the ICPC. So I guess I'll try to ask questions about some of those things that because I'm pretty sure most of you know most of the topics here. So I guess there's fundamental things like arrays and linked list, binary trees, heaps, and sorting. So I'm sure all of you know what the arrays are. So it's like a contiguous, like a space in memory that holds basically is the same data types typically. So you can hold like char, integer, and then related to the arrays, you can have vector or like you can resize the array size and such. So dynamic array would be called vector typically in C++. Array list in Java, and then list in Python, right? So, and then they typically hold homogeneous data, so string, char, integer, maybe object and such. But it's typically not a mixed data types, especially for C++ users, right? And a linked list is like for each of the node, you have a pointer to the next one, and that's the use case of the linked list. So the difference between arrays and linked list, you can actually, let's say, remove the element in the middle without actually suffering the cost of, let's say, pushing everything or anything like that. So it works faster when you try to remove the element. And then when you want to insert the new element also in the linked list, it works faster as well, right? So I guess binary tree, the tree property is like there's no cycle, right? And then binary means like there are 2 children for each of the nodes, unless you have I guess, like a leaf node, in which case you have 2 null pointers, right? So and then I guess a binary tree in the strictest sense, you can have at most 2. So you can have 1 or 0 as well, right? So when you do not have a children, you typically put null pointer there, right? And as mentioned, if you have the property that in addition to being a binary tree, if the node they're currently in is the maximum amongst your children's and yourself, then you have a max heap. And then if you have the minimum one, then you have a minimum heap. And when you have the left guys that are smaller and the right guys that are bigger, then you have a binary search tree, right? And now there can be, of course, equality. Typically, it goes to the left, but as long as you're consistent, there'll be no problem of you searching for the key. So it's fine either way. But I think it's typically implemented with the left one being, equality. So equal elements will typically go to the left. And sorting, the only thing that's pertinent here, I'm sure all of you know how to do sorting, but the sorting would be putting elements in the non-descending or non-increasing or non-decreasing order. And the key property is there are a lot of different sorting algorithms, but the most notable that you should probably remember is the merge sort. And let's say quicksort. Quicksort is best on average. So typically you can say in the average case you use quicksort, but in the worst possible case where all the pivot elements are let's say chosen wrongly, then you can actually shoot up the complexity to quadratic. Now, in order to avoid like shooting up the complexity high, even in the worst case, you can do merge sort, which in the best, in the worst, and even in average case is n log n. But the caveat for merge sort is it's slower, I would say, let's say in the average case, and it consumes a lot more memory. So you probably typically have to say those two things when they ask you a question regarding sorting, right? So quicksort would be the best one to use in practice. In most cases, but if you want to have the best possible worst case algorithm, then you want to do merge sort, right? So that's very typical thing to say for sorting. And if you say those two, then they won't be probably asking any more questions regarding this. But in practice, in the C++ or Java, there's a sorting things you can typically do. In C++, there's sort. Java, you can do sorted. And then Python, you also have a sorting function as well, right? So do not implement your own in typical, I guess, algorithmic context. You can use the in-house version, but make sure that you know the custom, let's say, comparator functions, so that when you have to compare, objects, you know how exactly to use the sorting function with the lambda expression, or sorting with the a custom comparator function, so that there's no issue of like sorting even very complicated data structure, right? It does come up occasionally in the programming contest, and so you should know absolutely how to use the custom comparator function. Right? Okay. Now, I want to say the important ones are stacks and queues, right? Stacks are coming typically in the depth first search. Queues are coming in the breadth first search. So queues are FIFO, first in, first out. Stack is LIFO, or last in, first out. Like the things that you put in last will come out first. And for queue, it's the opposite. So things that you put in first will come out first, right? And hash tables, the important concept is, there's a hash function, and you have to build a hash function so as to, let's say, guard the collision as much as you can. Now, if there's too many hash collisions that are happening, then you definitely typically go for, let's say, rehashing or creating hash function again, so that you can avoid them. And then there's a little bit of, I guess, art and theory that goes into coming up with the best hash functions and such, so as to minimize the collision. I'm sure some of you actually heard of like cuckoo hashing and so on. But the important thing to remember here is, I guess it might be quite hard to come up with the perfect hash function, but it's a theoretical discussion that you definitely want to have whenever there's a discussion about hash table. So just when it comes up, just discuss what hash functions are and what property you should nominally satisfy, and what are some ways to actually create a hash function. But the typical things you do is you multiply some like a number by a constant, add some constant there, and then modulo how many binnings there are. And typically, you'd pick for binning size like some prime number, and also the constant that you multiply and add. You want to pick some, I guess, sensible big prime number and such. But really, there's a little bit of art that goes into creating the perfect hash function. So, like I guess when it ever comes up in the interview, you can just say that like you want to come up with reasonable hash function. And I guess when it comes up in the programming contest, sometimes you do have to create your own hash function. But when it happens, just make sure that you are being extremely, extra careful with the collision resolution, because otherwise, it might run into time limit exceeded and otherwise. So it'll be quite important to not get into the, I guess, the time limit exceeded issue because of use of the, suboptimal hash function. So the difference between unordered map and map will be important as you discuss the hash function. But yeah, so there's that. And binary search tree, left ones are greater, right ones are bigger in the binary tree case. And as I said, the equalities are usually bunched with the left side. Although, as long as you're consistent, you can actually put them in the right side as well. And then the searching, what I meant by the searching is a binary search. But there's a little bit of art that goes into binary search as well, right? So, if you're looking for the first occurrence versus last occurrence, the midpoint, you have to update, let's say, left plus right divide by 2. That's typical thing that you do. But if you're looking for the rightmost point, then instead of using the floor, you want to use a ceiling. So you have to do left plus right plus 1 divide by 2 to look for the last elements or last occurrence of the something that satisfies the property. And something to watch out for if you're using your custom binary search is you need to absolutely make sure that your binary search actually terminates, right? So otherwise, you'll run into the time limit exceeded issue. And so in the while loop, you want to do extremely careful on doing left less than right, and the left less than equal to right, and know when to use pitch. So as long as you're consistent with your binary search implementation, you'll probably never run into this issue. But it took me actually quite some time to understand all the nuances that goes into the binary search, and that's one of the things I wish someone told me earlier, so that I actually do not get into this let's say issue of like a termination as such. But the binary search is one of those topics that are tricky to get right. If you do not have to use your custom one, then I would absolutely recommend you using the, let's say, language features. So set and vector, for example, in C++ has the lower bound that you can use, and lower bound and upper bound and so on. So I would encourage you to use them whenever you can. Only when you actually have to use your own binary search, sometimes you have to using the Oracle function. So then you use them, but you have to use them with quite a bit of care so as to not run into issues, right? And along with the binary search, of course, there's a ternary search as well, where you're trying to look for the pick points in the parabola-shaped, either up or down curve. And so, take a look at how ternary search in the integer case reduces down to the binary search actually, and it'll be quite important, I guess, topic to learn, because there have been some ternary search problems over the years in the Pacific Northwest and also in the North America Championship, and it does occur occasionally in World Finals as well. So definitely take a look at them. And finally, recursion with memoization is pretty much like the same thing as dynamic programming. So I would say dynamic programming is like a bottom-up approach, and the recursion with memoization will be top-down, but you should be quite comfortable using either one. And those tend to be quite important topics when it comes to preparation for technical interview in companies, right? And now, final thing I want to mention is there are some real differentiators in tech versus quant preparation, right? So all these topics that you see in this page, it may sound like a crazy list of problems, right? I mean, topics, right? So strings like Kunis-Morris spread, Robin Karp, string hashing, suffix array, suffix automaton. It's like unless you are doing programming contest or you're preparing for quant interview, those topics actually will never ever appear. But when you do for let's say quant interview prep or the algorithmic contest preparation, those are like go-to ones, right? So KMP and Robin Karp are string matching algorithms that you should know. So when you have two strings and you want to find whether one string exists in another, KMP and Robin Karp actually takes care of this in let's say linear in both N and M instead of naive quadratic. And string hashing is part of the deal when you actually want to use the Robin Karp. And then that's where you learn the concept of rolling hash and things like that. And suffix array it comes up when you're doing string matching as well, and the suffix automaton. And you can think of try as a way to think about the suffix automaton. And also there is closely related concept like autocorrosic. And I excluded the Z function from this list, but it does come up occasionally along with KMP as well. And then KMP, Robin Karp, and Z function, those are like a triple when it comes to string matching, right? And dynamic programming, there are quite a few of them. So 1D, 2D, interval, tree, and bit mask, and so on. You need to be absolutely careful. I mean, master those things. And I want to say maybe some optimization technique on top of dynamic programming, convex trick and Kunis optimization, and those things. It does come up occasionally, but most of the time, most of the people would have actually library or like a team notebook they can bring whenever you actually have to use those things. So, but my recommendation is familiarize yourself with the dynamic programming topics so that whenever it does come up, it's not going to be completely foreign object for you. And greedy algorithms, let's say appealing to the matrix, invariance, or induction. The key point is asserting something is greedy is actually the easy part. Proving so is the hard one. And you have to use invariance, matrix theory, and sometimes like an exchange argument to show that some algorithm that you proposed is correct, and it, in fact is greedy. And greedy algorithm is nothing more than having the locally optimal choice. And then it just happens so that local optimal leads to global optimality. And you can appeal to a lot of different arguments to show that your proposed solution is actually correct. And now for graphs, graph is a giant topic, right? So the shortest path is one, lowest common ancestor is another, flow matching is yet another one, and there's a minimum spanning tree. And then there are a lot more than what's actually covered here. So there are some decomposition techniques like a centroid and heavy light. But even on those main ones, there are a lot of subclasses, right? So in the shortest path, in the unweighted graph, you have a breadth first search and depth first search. I'm sure most of you would know this one. There's a Dijkstra for weighted graph. And then Bellman-Ford if you have negative weights. So Dijkstra would have a non-negative weights. Floyd-Warshall for all pairs shortest path. So those are quite common things to know all as a package. And like, depending on the graph and what you're given, you have to use different things among the things that are listed here. And the flow and the matching, Ford Ferguson and Edmund Karp to start. And then most of the time, when you're in the actual programming contest arena, you'll use DNIC, and that's really important one to use. And for minimum spanning tree, I'm sure you know what they are, but you're trying to find spanning tree, meaning the tree that spans all the nodes, or you have to use edges so that all the vertices are covered by at least one of the edges. And you want to make sure that the sum of the weights in those the edges that you selected is minimum amongst all the spanning ones, right? And there are two different techniques to solve them. One is prim, and the other one is Kruskal. Prim works by starting arbitrary vertex and then growing the smallest edge that emanates from it. And the caveat is you want to do it while not creating any cycle, right? So if you pick an edge that emanates from the connected components that you have, then you want to not use them. And then whichever actually gives you the maximum, the minimum at the end, meaning you try to grow one at a time without creating a cycle, and the connected components just grows one at a time. Whatever actually you get at the end is guaranteed to be the minimum one, and it's a classic example of greedy. And it does take some argument to show that that is the minimum one. And then another one is a Kruskal, and for that one, you sort the edge weights from the smallest one to largest one in the graph, and then you actually use all the edges like that do not create a cycle when you're actually putting them into the proposed tree. And now, as you can tell, like those two approaches are similar but quite different in practice, right? And so Prim's one, you're editing one at a time the edges that are minimal, and to create the one connected components in each time of the iteration. Kruskal typically have a lot of it, I guess disconnected components that are small enough that doesn't have a cycle, and at the end you'd have a one, like a minimum spanning tree. But the process is you'll be typically joining the disconnected components one at a time, and so there's an important data structure called disjoint set union that comes into play. And so you should know how to implement the DSU using, there are two operations that are important there. So union and find. So they call it sometimes union find, and some other times they call it disjoint set union. But either way, the important optimization that you do on top of the typical implementation is path compression, and also union by rank or union by size. So it's really important to know the DSU, the ground up. But pretty sure the audience here, based on your background, you will know some of those things quite well, while others, it's like, let's say, it's probably hard to know everything here in detail, although most of the things are probably familiar, right? So my ask for all of you here is, especially if you're trying to go for interview in the quantitative company or trading company, or let's call it like a high frequency trading companies, then do take some time to take a look at these topics, because they will come up in some shape or form. And I want to say that if you're going for the regional contest, Pacific Northwest, then I would say for those as well, some of the topics here will be like frequently occurring topics. So I would highly recommend going through at least all the topics here, and then make yourself familiar. If not, have a, let's say, team notebook that you can actually bring to the contest so they can use them to score better, right? It can come up in some surprising context and otherwise, but I think if you prepare the real differentiators, important ones, and the basic ones, then you'll probably have enough to maybe score relatively well in the regional contest, I would expect, right? So I guess with that, I actually want to go through one a quick warm-up problem on string, right? So I actually gave you the slide for all of you, so it's possible that you actually have seen the solution by going through the next page, but it's fine. But I want to make sure that you guys know at least how to do this question, which is minimum number of insertions to make a string of palindrome, right? So, by the way, palindrome is a string that reads the same forward and backward. Right, exactly. So the constraint is really important, and so I'll tell you that string is at most 5,000 in length, and each of the the characters in the string is for simplicity lowercase a through z, right? And so with that said, do you guys have any idea on how to solve this question? DP, or like a two-dimensional table, I call it DP. Let's say from I to j counts the minimum number of insertion that you need to have from I to j, right? Now, depending on whether I and j are the same, like character-wise, so s of I and s of j is the same or not, it gives you rise to two different cases, right? So now, if si and sj are the same, then without actually incurring any cost, the answer to the like I through j will be actually answer to the I plus 1 and j minus 1, right? Because a priori they're matching, and so we actually do not have to do anything, following the definition of palindrome. And now, if they're not matching though, then it does incur a cost of 1. But when you do that, you also know that there are two choices, right? As I said, I becomes I plus 1, while j stays the same, or I stays the same while j goes to j minus 1, right? So the idea is the answer to the case I through j will be the minimum of I plus 1j and I and j minus 1 while incurring the cost of 1, right? And then it turns out that on this question is a typical two-dimensional dynamic programming. So in the case when I think I guess in this loop I call it j and k, but if j's character and then k's character match, then you can actually do j plus 1 k minus 1. And otherwise, if they do not match, then you have two choices: minimize those two cases and add 1 to the answer. Now, one caveat is one assumption that we actually have to do is dynamic programming. All the previous cases actually should have been already computed. But in this particular case, what you notice is either these two cases, either the length of the string decreased by 1 or 2, right? And so if you process our let's say dynamic programming table in the orders of the increasing length of the substring that you're considering, then we're good, right? Because when you're considering length L, then length L minus 1 and L minus 2 would already been computed. And so when you actually put those two ideas together, what you notice is in the outer loop, I going from 1 through n minus 1 is going to actually keep track of the length of the substring they're considering. And the for loop inside will take care of whether we are looking at the index j to k, and depending on whether the string at index j and k match or not, we have two cases to consider, right? And by the definition of this dynamic programming table, it's a two-dimensional DP table, and the answer that you're looking for is from index 0 through n minus 1. So the return that you do at the end is going from 0 through n minus 1, which is the entire string, right? So if this makes sense to everyone in the audience here, could you put thumbs up so that I can tell that you guys actually understood the logic behind this implementation? Yeah, Raymond, you have a question, or is it? Oh, maybe you thumbs up.
I have a question. So
yeah,
for
sure.
the inner loop of the solution,
Mhm.
could you briefly explain the inner loop of the solution? That's the only thing I'm having a little trouble on.
Sure. So I guess this part, right? So j 0, yeah. So so assuming that we are processing length I now, then or I plus 1, I guess. But the point is, what you're doing here is you're going from left to right, and each time you have two cases to consider, depending on whether the jth character and kth character match. And j is going from left end of the string to the as far as you can go to the right end without, let's say, the right end point actually going to the end of the string, right? And for each of those j to k, you have two cases to consider, depending on whether jth character and the kth character match in the string. If they match, then without actually incurring any cost, j can advance to j plus 1, and k can decrement to k minus 1, right? So basically, what this means is the answer from j to k index, it rests on having computed the value for j plus 1 and k minus 1 because they actually already match. So if the strings match, then we can, without actually incurring any cost for palindrome, like the definition, we can actually go in, right? And then match the rest of the string. But now, if you already know the answer for j plus 1 and k minus 1, then the computation is already done. And that's where the deep dynamic programming comes into play. And now, if the characters do not match, then as I said before, there are two cases to consider. You can actually match the jth character and then just advance that once, so j plus 1 and then k. Or you can match the kth one by inserting a character that matches the k in the jth end, and then decrement the k to k minus 1. And then those two cases, each of them, you actually have to insert a character to match. And, I guess the other one basically gets fixed, right? And so at the end of the day, if the characters do not match in the jth one and the kth one, then you have minimizer of these two expressions at 1, because you actually inserted the character explicitly to match the character there. And then you're trying to find the answer for j to k minus 1 and j plus 1 to k. But again, because it has a smaller length now, because we actually removed the character from j to k, we already know the answer for this already by dynamic programming, because we're actually increasing the length of the string as we go, right? So in the second case, we decrease the length by 1. In the first case, we decrease the length by 2. So either way, we already have computed the answer, assuming that I equal to 1 through I less than n. That outer loop hasn't taken care of length. I mean the case where length is 1 or 2 shorter than the current string. So does that make sense, Raymond?
Yeah. Okay. Thank you.
Okay. Yeah. So I guess this will be a quite terse implementation of the this minimum insertion for palindrome, let's say, problem. But this would be like a reasonable problem to expect in the interview. I would say, it used to be, I think, when I was doing the interview, I was asked this question like 3 times, in 3 different companies actually. And so that's one of the reasons why I'm actually using this question. I'm pretty sure now it's probably not the question they'll use because it's overused at that point. But nonetheless, it's a good question to test, because if you do not have this dynamic programming idea handy, then the implementation quite big, quite clunky and otherwise. But I think having this like very terse implementation of dynamic programming idea is going to be quite important to do well in the interview. And also, when it comes up in the programming contest, you can actually now be able to solve this kind of questions quite fast, right? Yeah. So now, the idea here is any questions in the interview will have a problems of this sort. And to go back, when you're asked the question, make sure to clarify the constraints and give the interviewer, or like in the problem, in the program context also, like a very clear sense of direction before you start implementing. That's the key. And when you're actually implementing the solution, try to give as concise and terse of a solution as possible without getting it wrong, right? So that's really the key. And then if you're a Python user, then you don't need this like a vector of int and so on. So you can already see why your solution will be a lot shorter than what we have. So int and vector of int and so on, we don't need any of that because Python, you don't actually have to write variable like a type explicitly as a prefix. So your code will be a lot shorter, right? Okay. So with that said, I want to give everyone here highlight of what you can expect in the tech interview and how you can actually go ahead and prepare for them. So the benchmark that I typically use for leak code, weekly and biweekly contest, is probably the only contest that I would expect that you guys will be able to do without losing, like, let's say, sleep and such, because the weekly contest happens at 7:30 Pacific time, and PM in AM. So AM one might be a little bit tricky, but the PM one won't be. Typical benchmark that I give everyone is 60 minutes to solve all the 4 questions. So 30 minutes and 6 minutes, 12 and 24 minutes for each of the 4 questions. And in case you get some questions wrong or some questions may take a while, I give, let's say, 15-minute buffer. So that's very typical. Codeforces getting a rating of 1800 plus would be good. So that would correspond to solving about 4 questions out of 6. And then, at coder, top coder, and code chef, those are good problem size to do as well. But my experience has been that like Codeforces would be sufficient for most purposes. But The timing of the contest is a little bit bizarre. 7:30, 6:30, and then 7:30, in the summertime and such. But regardless, my expectation is you may want to do virtual contest for most of you. And at quarter, the contest timing is even weirder. But the contest, those are good problems to solve if you want to get better in solving some simple questions fast. And so at quarter beginner contest especially, I would recommend it for I guess the audience here. In the quant interview preparation, the distinction between this slide and the previous slide, you'll see that the time has decreased by threefold, right? So the lead code, 20 minutes. So 1 minute, 2 minute, 4 minute, 8 minute with a 5-minute buffer. That's a pretty harsh benchmark, but anyone that hits that benchmark, I've actually seen almost everyone having that benchmark to actually pass at least one quant interview. So that's a good benchmark to hit. And code process rating wise, 2200 plus. So they'll be solving 5 questions out of 6 fast. They'll be, I would say, sufficient for most practical purposes. You don't need that quarter, top quarter, and coach chef, but if you want to complement those, preparation, that'll be good ones to do. And the annual contest Meta Hacker Cup, if you do sufficiently well in that one, then you don't actually have to do any of the application. They will actually invite you to do interview with them. So the typical good benchmark to hit would be if you're good enough to get t-shirts from them. I think it was top 500 and top 1,000 recently. Then you'll be auto invited to their interview process. So I think that you can think of the Meta Hacker Cup as the for them to get the interview pipeline. And so if you do well there, that's a good way to showcase your algorithmic solving ability. And then Google Code Jam and Top Coder Open, they've disappeared as of last year, although I heard that they might reinstate them in the future. So, and as I mentioned, Competitive Programming 4 is a good reference, especially for competitive programmers. And the elements of programming interview would be like a reasonable one to use as well, right? And I think there are some behavioral things that we can go as well. But given time, I'll be brief on this one. The key point here is becoming an industry standard for everyone to at least have one full behavioral interview loop at this point. So it used to be that it was part of each of the sessions that you do as part of the algorithmic questions, but now it's becoming more and more like part of the full interview loop. So they tend to have 45 minutes to 1 hour assessing your leadership potential and then testing your interpersonal communication skills, effective communication, conflict resolution, and things like that. It's not really about getting it right or wrong, though. In stark contrast to the algorithm and data structure, it's really open-ended typically, right? So questions like, tell me about a time when you led a team to successfully complete a project is one example of what they do. And typical sample answer to this is to provide hackathon or passion projects you've done. That really that showcases every package. But every audience of the ICPC, you have this almost for free because you can actually discuss about the ICPC contest experience, right? So if you go to regionals and you've done some preparation towards that throughout the semester, then it's really a good one to highlight. So I would definitely do that. And then if you've been an intern in some company and that you liked the project that you worked on there, then you can highlight them as well. So the key portion here in the sample, this sample question is being concise in your description, giving some hard metrics like percent increase or throughput increase and maybe the latency decrease in terms of a percentage, or showing the dollar amount if you have them, or the how many participants or how many hours of practice and etc. Any metrics that you can give that are like a concrete and hard, those are good. And then you want to provide concrete examples. So internship projects, research projects, and maybe the best one that I've seen come through is if you've done the ICPC and you've been doing it in a weekly basis, and then if you can also demonstrate how much of an improvement did you get from practicing with others, those will be a very good response to this, right? And for example, like how do you set up priorities for the work you're facing each day? For this example, I typically hear the priority queue idea. So getting the most essential things done first, then respond to emergencies as needed. And like at this point, non-essential tasks will be sort of delayed, maybe indefinitely, but there might be no problem there because I mean, you don't expect to get non-essential tasks to be done over essential ones. So you just have to have a reasonable answer prepared. What if you never get any tests done? They're non-essential. And what you can say is, like typically you want to prioritize the ones that are important, right? And that's typically good answers to give. And finally, what experiences do you have relevant for this job? I think I've been getting this question as a interviewee, and also I asked this question a lot to the as an interviewer. And typical good answer would be highlight a technical project they've done that lasted at least 1 year. Again, ICPC could be a good like experience to tell. And if you've done some research project that spent a long time, that's another one. And then, if you interface with the professors to work on some research or exciting side project, that can be another one. If you interned in some place for extended period of time, that can be like a reasonable one as well. So in this particular question, it's actually, I mean, they're looking for what specific, let's say, skill set can you actually deliver. And so talking about technology is really the must. So programming languages, like what programming language do you know? What database have you used to complete the project? What algorithm and data structures have you used? So in particular, if you're using ICPC as an example, then you have a lot of examples to give on this one because each one involves a different algorithm techniques. And then you can also talk about Emacs versus Vim versus JetBrains, Visual Studio, and etc. that you used as a developmental tools, right? So I would expect that all those questions, if you prepare let's say with some dedication, then it won't be a hard question to answer typically. But I do want to make sure that all of you know that each company that you apply for typically have a list of core values that they really like to let's say advocate for. So for example, Amazon, if you search Amazon and core values, then you'll see a lot of leadership principles and otherwise that they really care about. It's, by the way, growing list of things. So when I first looked at their website, it had only 5 things, but now it has 20 plus, I think. But the point is, you want to basically prepare at least 1 or 2 examples that demonstrate your excellence in that domain. So that'll be the preparation work that you do prior to going to the behavioral interview. But if you do that, then when you actually go for the interview, it'll sound quite easy because most of the things you already have the prepared answer for. But I guess it's okay to show how much of a preparation you've done to demonstrate the excellence. But this will probably, like I guess the advanced tip for all of you would be do not make it seem like you already have the prepared answer for all of them. It may be like a reasonable idea to make it seem like it's prepared impromptu sometimes, right? So that's a good idea. But like as a seasoned like an interviewer or interviewee, most of the time you can tell how much of a preparation actually has gone into preparing the answers. But it's typically quite easy to tell whether you have the behavioral questions actually done at least some mock interview or otherwise. So make sure to do some, but you don't have to spend, let's say, a lot of time on this. My ask is, especially as an entry-level engineer, spend time on the algorithm, design and data structure portion more than this portion, right? So yeah, there are some good books to read that I actually used when I was preparing. So Horatio Bird has a behavioral interview questions and answers, and Vibrant publishers have a leadership interview questions. Although I can tell you that the second book may or may not be needed for you because this book is really for, I guess, people who have let's say 5-year plus of experience, and maybe those who are going for more leadership, or managerial, I guess, job search. Although, it's a good book to have, let's say 5 years to come, so that when you actually need to review the leadership principles and how do you do preparation for that, that will be the go-to book for that. Those two books, other than those two, I haven't actually looked at anything else, and I think those are more than sufficient because they give you like model examples or model responses as well as the answers that you should try to watch out from giving. So it's a good way to practice both plus and minus of the behavioral side, right? And finally, the only comment I would like to give on the system design portion is it's really used to be not for the entry level, although it's getting more and more eased into the entry level positions. So I'll give you a highlight on what you do here. So you need to identify large components of the system and describe how each of the components is connected. You know, like let's say backend, front end, database, and so on. The actual implementation details are not important. And in fact, I would stay away from giving too much implementation detail unless they ask you and they test whether you can design a architecture using standard design patterns like modularity, object-oriented principle, and such, right? And so in this one, the must reads, in my opinion, are system design interview by either Luis or Alex. But my ask is system design may or may not be part of your interview loop. So when you get the interview from the companies, do ask them if they expect you to know or prepare for the behavioral and also system design. And if they say no, then you actually do not have to. And some companies actually do not demand this. So it'll be, I think, best interest for you to find out like whether you actually have to prepare for those or not. But most of the big tech, I think nowadays are going to have one loop in behavioral, one loop on the system design, and maybe 2 to 3 loops on the algorithm and data structures. So that's what I know. And now, if you want me to give or present this material and more to your university, you can actually send me a quick chat as before. I guess it could be relevant to Ben and Chris. And the one-on-one quick chat, if you'd like to have a quick chat with me, I would definitely recommend it. I can help you with 2 explicit things here. So one is goal setting with respect to the programming contest journey that you like to do. And then the second thing is to help you landing a dream job, right? So I think that's really the presentation materials I gave today. So if you'd like to, feel free to send me a quick chat request, and I'd love to chat with you. And I'd like to, I guess, advertise a few more things. So the ICPC Foundation is always looking for an intern. I think Ben knows about them, certainly. And if you'd like to throw the resume to me so that you would like to be, if you'd like to be considered for the internship, that'll be great. Especially relevant if you're international students looking for F1 OPT sponsorship. But of course, if you have your authorization to work in the US, if you're like a US citizen or permanent resident, you're more than welcome to apply. There are a good mix of both in the organization, the ICPC Foundation as interns. So we'd love to hear from you. So website development is organized by Tony and also Glenn Dunning, and problem solving and then problem archiving by Frederick. Frederick is actually the creator, co-creator of the Caddis. And so those are the projects that are actively looking for more interns at the moment. So it'll be a great way for you to contribute to the ICPC in positive way. Yeah, so there's that. And so with that said, I would like to leave some time for questions for any audience member that are still with us right now. So if you have any questions, this will be a great time to ask.
I just had a general question. I was going to ask how you and I guess the rest of the more experienced members of this meeting got interested in computer, or I keep saying computer, competitive programming.
Yeah, I think that my journey actually started with the competitive programming. So my friend just dragged me along to the regional contest, or no, not the regional, but the local contest at Stanford. And he was like, "Oh, you should try to do these problem sets." I went there without knowing actually how to program at all. So I was able to like think about theoretically how to solve them, but I wasn't able to write any code. So you can say like I would bomb the contest, and that's pretty much what happened. So in the very first introduction to programming contest, I got I think the -15 compilation errors or something, but expectedly. And then I practiced quite a bit after talking to some of the students on how they prepared. And the year after, I was in second team, and then ever since I was in second team. So I was second team twice, one as the sixth member, and then the second time as the fourth member. So that was my experience. Maybe Chris and Ben, you have a different experience here.
Sure, I'll share my experience. My first experience as a competitive programming was actually as an elementary student in the 80s. In the 80s, they actually had a bunch of programming programs for children, which has sort of disappeared in elementary schools. But I was encouraged to do competitive programming in a language called Logo. Some of you might remember that
Oh, wow.
one. And I actually won, so I was quite impressed by that. And then, but when I was in ICPC or in college, I was an algorithms TA, and the coach in my school came and asked me, he said, "Did you want to be on the team? I know you TA the algorithms class." And I was working on my master's. I said, "No, thank you. I've got other things to do." And he said, "Well, the World Finals this year is going to be in Hawaii." And I was like, "Okay, you know what? I think I will try out for that." And we did manage to make it to the World Finals that year. So that I was motivated by a trip to Hawaii. And here I am 22 years later, still involved in the contest because I really do love the experience and the competitive, and just seeing the teams competing even decades later, it's a lot of fun. So that's where I
And
am.
I'm sure you're motivated by going to Egypt and going to the the Astana.
I haven't been to the World Finals since Hawaii,
Oh,
but I
okay.
did go to the North America Finals last year. So that's a
Nice,
trip
nice.
to
Woo,
where
okay.
was that? Florida? That's nice enough.
Yeah. So I guess I might see you in Bay in the May then, I guess, right?
I might see you in May. That's correct.
Woo. Okay. And Ben, how about you actually?
Yeah, so I was a math major as an undergrad. And we had this professor from
Good.
Bell Labs. Bell Labs was super cool. That was the thing back then. And he put together a team to go to Purdue University to compete. And um and so he recruited me, and I just remember, like, up till that point, programming was very much like pipe fitting, right? I mean, you basically, oh, I want this button. We didn't have buttons, it was all text based. But basically, I want this button to light up here. Oh, when this happens, I want that to happen over there. Oh yeah, I need to like process this file. Let me just loop through everything and do whatever I want to do. It was very straightforward. I mean, nothing was really that deep. And then suddenly, I just remember counting stars was the first problem we worked on at our competition practice, like the warm up. And I had this like iterative approach that didn't work at all, but it worked for my test cases, right? Where you counted the stars by just going through the grid and like doing some sort of goofy tracking. And then when I saw the recursive solution, it just, like, I don't know, something just clicked inside of me, and I realized that programming was so much deeper, and you could do so much more cool things if you really had the tools. And that just, it was very inspiring for me, and I really enjoyed it. And so then, yeah, that's why when I came to SJSU, I'm like, I want students to feel
Yeah.
that too.
Right. So it's like since you felt so much a joy of doing the problem solving, you want the students to feel that too, I'm sure. And that's what got me interested as well. And I was actually a math major as well that got converted to CS. So hooray for us, I guess, right?
I mean, in fairness, I was math because we didn't really have computer science at my school. So I mean, we did, but it was more like, yeah. Anyway.
Sure, sounds good. Yeah, so I guess you heard from three of us, and the recurring theme is you're doing it for some motivation, but if the motivation is for fun, then you'll stick around for so long, and then you become actually one of us, right? So that's really the recurring theme here. Any other questions from any other one in the audience? If not, then I guess I have the contact information. So Christian Lim at ICPC Global. You can also see my personal website as well as a LinkedIn. So if you'd like to add me there, you can add me. And if you'd like to send me an email, please do. I'd love to hear from the students as well. And if you have a feedback about how to do better next time, even better. So either way. And with that said, let's end here and give, I guess, Mike back to Chris, and I would like to actually thank him again for having such a great session organized. So.
And thank you to you, Christian, for dedicating your time for this session. I'm sure all the students that were here found it very valuable, and I'm sure we'll have an opportunity to do that again, and maybe I'll see you in May.